So the next chapter that we are going to cover is probability. This is again a very important chapter and a very conceptual chapter and has a very important weightage in IIT JEE. Getting started with the first problem, we are given that 4 objects A, B, C and D are there and they are sent to 4 places 1, 2, 3 and 4 randomly. What is the probability that none of A, B, C or D goes to its own place? To start with this problem, let us first find out the total number of ways in which A, B, C and D can be placed at these 4 positions. The total ways are 4 factorial, because A can be sent in 4 ways, then B in 3 ways, C in 2 and then D in 1. So it is 4 factorial, the total number of ways in which A, B, C and D can be sent at these 4 places. Now the total number of ways in which none of the object occupies its own place is equal to total minus 1 object occupying its own place plus 2 objects occupying its own place plus 3 objects occupying its own place. But if 3 objects are occupying its own place, their own places, then definitely the 4th object will also occupy its own place. So this case is same as all 4 objects occupying their respective places. The total number of ways are 4 factorial, which is equal to 24, minus, if one object is occupying its own place, let us fix that object to be A. It is going to 1. Now we have 2, 3 and 4. Now B cannot be sent to 2 because it is the place of B. So B can be sent at 3. Let's say one case. Now D cannot be sent at 4. So D has to go to 2 and therefore C will go to 4. This is one of the way. Or B can be sent instead of 3, which we took in the first case, to 4. Now C cannot go to 3, so it has to go to 2 and D to 3. So there are 2 ways in which the other 3 objects B, C and D don't go to their respective places. But in this case we have fixed A, and there are 2 ways of choosing, or rather 4C1 ways, that is 4 ways of choosing that object that has gone to its respective place. So the total number of ways in which these 4 objects, out of these 4 objects, one object goes to its respective places, 4C1 into 2. This is the answer for this part. Now let us find out the total number of ways in which 2 of the objects occupy their respective places. So let us say A and B occupy their respective places 1 and 2. Now there is only one way to send the remaining 2 objects, because C and D cannot occupy their respective places, so C has to go to 4 and D to 3. So there is only one way. But since we have fixed A and B in this case, so the total number of possible cases are 4C2 to select those 2 people which are going to the respective places. Into 1 are the total number of ways. So the total number of ways in which 2 objects occupy the respective places are 4C2 into 1. And if all the objects are occupying the respective places, there is only one way. So this is the total number of ways in which none of the object occupies its own place. What we have done is we have found out the total number of ways in which the objects can be placed and subtracted those cases in which one object is occupying its respective place, 2 objects are occupying the respective places, and all the 4 objects occupying the respective places. This becomes equal to 24 minus, this is 4 into 2, 8 plus 6 plus 1, this is 15, 24 minus 15 is 9. So total number, or rather the probability for this to happen is the favorable cases divided by the total number of cases, that is 9 by 24 or 3 upon 8, and this is our final answer.